Hello students, good morning to all. It's really happy to meet you again in this class. This is Gopal from Department of Chemistry, Bharadasana Matriculation Higher Secondary School, Arakonam. Today we are going to see 11th Chemistry, 6th unit, Gaseous State. So this unit is the first lesson of the physical chemistry. From this lesson we will study the physical chemistry related lessons. The gaseous state simply denotes that the particles made up of gases. In the previous standards you already studied about physical chemistry, in which you may studied about the solid state particles. Likewise, the gaseous state matters are considered in this lesson, in which we will discuss about the gas laws. So that is the basics of the gaseous state lesson. Let us see students, the gases are used in wide ways in our everyday life. For example, let us consider the LPG gas. This gas is liquefied petroleum gas. Simply it is denoted as LPG. This gas is nothing but the mixture of the butane and propane gases. Mostly butane and propane are mixed together. In sometimes many other gases also may be used to produce liquid petroleum gas based on the qualitative information. And the helium balloons also an example for the gases. Helium gases generally have very low mass. So when they are occupied the balloon, they moving freely to the atmosphere, and the helium balloons can easily reach the atmosphere. So it will be fly in the higher height. And the gas pumps, you already used it for the cycles, you know. So these are the uses of gases. In everyday life we use gases in many things. And next we need to see how the gases are differ from solids and liquids. Let us consider the solid, liquid and gaseous states, in which the solid contains the molecules very close together. So the intermolecular distance between the atoms is very low in solids. But what about the liquids? You all know that the liquids can easily flow from one place to another place. So the intermolecular distance slightly higher than solid. But what about the gases? You can see inside the chamber the gas molecules are very long distance keeping. So the distance between the atoms is very long. Intermolecular distance between the gaseous atoms is very long. So that is the difference between solid, liquid and gaseous molecules. So due to the distance, the bond attraction between the molecules also affected. If the distance is very long between the atoms, the bond attraction also being less. If the distance is very low, the attraction is more. Much more attraction is obtained by the distance between the molecules. So whatever the gases keep a longer distance, so the attraction between the molecules are very less. So gaseous molecules can easily freely move to all the places. So only atmosphere gas easily moves. In the latest news you already studied about the cyclones, the never cyclones are coming, you know, because of the flow of gases at high speed. The speed of flowing is very high to the gases, and based on this we can measure the pressure, temperature for the gaseous particles as their properties. Today we will see the properties of gases, for example number of molecules, temperature, pressure and volume of the gaseous particles. Let us consider about the pressures. In liquids it can contain more pressure than the gaseous particles. So the pressure is high. Generally the gases contains low pressure. So here the pressure is low. Likewise you can consider the gas with the solids. Solids have very strong contained material and gases are very less attraction to particles, so they are very less attracted molecules. By knowing them we can separate this into the formulas. Let you see the formulas now. The gaseous properties are based on the formulas. In the formulas you can see the properties are differed by the different properties. Let us see, gases have no definite shape. It is the first point, because the gases do not have a fixed shape, and gases are don't having the fixed volume, because the volume of the gases differs according to their pressure, and gases are so far apart in its molecules, and gases do not attract much more, they just least means minimum attraction only it have, and gases movement are maximum because its low attraction they can easily move to all the place. Gases have high kinetic energy. Why the gases have high kinetic energy? Because when the gas molecules move from one place to another place, it shows its energy as a kinetic energy, and the diffusion between the molecules is maximum for gases, because the diffusion is nothing but the gases breaks its bond between the atoms, that is called as diffusion. Diffusion generally maximum for gases, because of their properties, their characters are arranged like this. By knowing this, you can write the formula. Generally, the gases have three formulas. These formulas are laws, gaseous laws. First formula, Boyle's law, and second one, Charles' law, third one, Avogadro's law. If any gases obeys three laws accurately, that gases are called as ideal gases. So, ideal means it is a good gases. So, ideal gases generally obeys Boyle's law, Charles' law, and Avogadro's law. What about the Boyle's law? Today we only discuss the Boyle's law. According to Boyle's law, pressure indirectly proportional to volume. When pressure increases, the volume decreases. When the volume increases, pressure decreases. So, that is the main concept for Boyle's law. Let us see Boyle's law experiment. So, if you consider one experiment technique according to the Boyle's law means, when you give a pressure, the volume certainly reduced, because the pressure can increase the attraction between the molecules, so that molecules come closer, so it takes less space. The less space can decrease the volume. So, if you mark the pressure and volume points, after that if you draw the curve means, it denotes that when the pressure decreases, the volume increases. You take x axis as a volume, when the volume increases, the curve can go to the right side. When the pressure decreases, it comes from upwards to downside. So, the graph denotes that pressure decreasing and volume increasing. You can write this law as P indirectly proportional to volume. So, P1 indirectly proportional to V1 and P2 indirectly proportional to V2. When combining these formulas, you can get P1 V1 equal to P2 V2. So, the V1 multiplied by P1 and V2 multiplied by P2. So, you can get P1 V1 is equal to P2 V2. So, this is the general mathematical representation of Boyle's law. By knowing Boyle's law, you can understand the another laws also. So, this is the first main law of gaseous laws. If you know this law, you can easily understand the next two laws, Charles' law and Avogadro's law. What about them? We will see in the next class. Thanks for making time to watching this video. Thank you, students.